Hello, and welcome back to Shikshit Costa. Today we're going to solve problems involving exponential relations. In this lesson, you're going to learn to solve problems involving exponential relations that arise from real life. And you're successful when you can pose problems. In other words, when you can look at a relationship and ask your own questions and say, how would I figure this out? And then solve them by using a given graph. So you're not expected to be able to solve this algebraically, just using a graph. And that graph could be given to you, or it could be generated using technology. And then once you've posed and solved these problems from this graph, you also need to be able to solve problems when you're given an equation by substituting values for the exponent into that equation. So nothing terribly difficult. Let's get started here. The value of one share of Lariat Studios grows according to this equation. Now remember, a share is one little piece of the company. This company is split up into many little pieces, and they sell them to people so that they can raise money and develop their product. And later on, the company is more valuable. So each piece of the company is also growing in value, and it grows according to this equation. And we can see that, this explains that X is the number of years since 2010. And what you can do here is pause this right now, fill out this table of values, and then sketch a graph of it to see how quickly this one share is growing over time. So how do we fill out this table of values? For the first row here, we can see that X is equal to 0. So I'm going to take my equation here and I'm going to replace X, of course, with 0. And so the value of V is calculated by taking 100 and multiplying it by 1.1 to the power of 0. And what is anything to the power of 0 going to equal? 1. And so 1 times 100 would just be 100. So, of course, I could have known this as well just by looking at the initial value is always this number in front that is being multiplied by the power. And so I know that when, in 2010, when 0 years have passed, the value of this share is $100. After 1 year, it grows. To find out the value, we do the same thing. We take the value of X as 1, we plug it into our equation right there, and then we evaluate 100 times 1.1 to the power of 1. 1.1 to the power of 1, of course, is just 1.1, and 1.1 times 100 is 110. And I can keep repeating this for every single row, right? To the power of 2, X is 2, and I put this into my calculator, I find out it's 121. And I can keep going and filling out this entire table of values just like that. Now it's time to graph it. And I'm going to use some software here. I'm going to put this into my spreadsheet software and then click Insert Chart. And that will give me a beautiful graph just like this. So this is how the value of one share is changing over time. You can see it's increasing, it's increasing. In 2016, which is 6 years after 2010, this share, I could now sell it for almost $180. Now this is a bigger graph. Notice that this doesn't just stop at 6. It goes all the way to almost 50. And we can see that value of our share, it increases quite slowly at first. And then it quickly picks up how much value it's increasing by. It's still only increasing by how much per year? What would that growth rate be? It grows by 10%, right? This base is 1 plus the growth rate, which I can see right here, 1 plus 0.1 would give me 1.1. And so the growth rate here must just be 10%. But 10% of a big number is actually going to be a lot bigger than 10% of a very small number, which is why this is increasing faster and faster. So if you started working in 2010 and you started saying, oh man, one day I gotta retire. I need some money so that when I stop working, I can continue to afford all the things that I like to buy. I can continue to afford my meal kits at home, and I can continue to afford going to nice restaurants and traveling and buying the latest video game consoles. So when you retire, your investments need to actually be worth quite a bit of money. So if you started working in 2010 and you decided to save $100 of your money in Lariat Studios investments, in their shares, how would you find out how much your investment is actually going to be worth, how much you can sell it for when you retire? Think about this for just a minute here. Pause this and think about how will you find out how much your investment is worth when you retire? The trick here is to realize that it really depends when you want to retire. Right? If you want to retire in 20 years, you would replace X with 20, and then you could use the graph to find out how much that retirement is worth, or you could even use the equation. Suppose you wanted to retire in the year 2047. How much will your investment be worth at that point? Well, 2047 is 37 years after 2010. And so I would go from 37 on the x-axis here, this is the number of years, straight up until I hit the graph, and then move straight to the left until I hit the y-axis, and that would tell me just a bit above $3,000, maybe $3,300, something like that. So my dinky little $100 investment, I didn't do anything myself. I didn't do any work to have it grow to this value. All I had to do was wait 37 years, and then I can sell it, and it'd be worth $3,400. So I could use a graph, but that's kind of inaccurate, right? It's hard to tell exactly where this graph is actually impacting here. It would be much easier if I used the equation and I replaced X with 37. And then 100 times 1.1 to the power of 37 would give me $3,400.39. So when a situation involves an exponential relationship, a graph or an equation could be used to find out more information about that. If we're using a graph, all you have to do is find the value of the independent variable, so the one that you're controlling, and then you trace a vertical line up or down towards the curve, towards the graph that you're actually seeing. Then once you hit the curve, go horizontally until you reach the y-axis to find the value of the dependent variable, which is usually y. But an equation is a lot easier, right? To use an equation, simply replace the independent variable, which is usually x, with its value, and then you just evaluate that expression. And that's exactly what we did in our lesson today. Let's do an example here. Every time an arrow moves through a force field, it loses 10% of its speed. So that's my arrow. It's got 3 force fields here, and it has to go through all 3 of them. And it's going to lose 10% of its speed every single time it passes through a force field. How fast would it strike its target if it was shot at 100 kilometers per hour and it goes through 3 force fields? Pause this here for just 2 minutes and see if you can figure this out. And if you need help understanding what's happening here, remember that this arrow is starting at 100 and then it goes through a force field, and now it is at 90% of its previous speed. It lost 10%. And now it goes through the next force field, and again, now it's at 90%. It lost another 10%. So now it's 90% of whatever it was over here. And after the third force field, again, it's at 90% of whatever its speed was when it was after the second force field. So how fast is it going now? So hopefully that was enough time. And how I would create the equation for its speed currently is I would start at 100, and then if it loses 10%, now it's at 90% of its previous speed. 90% of means 90% is 0.9. Of means multiply. So I would take 100 and I would multiply it by 0.9. Multiplying by 0.9 would get me the same thing as multiplying it by 0.1 and then subtracting that number from 100. And then whatever number I get here, I need to take all of this and multiply it by 0.9 again to find out the arrow's speed here. Because here it is 90% of this speed. 100 times 0.9 is 90. So over here, the arrow was going 90 kilometers per hour. And then that 90% of 90 is actually 81 kilometers per hour. So it didn't drop by another 10 kilometers per hour. It doesn't drop by 10 every single time because 10% of 90 is 9. And so it only went down to 81. And then I multiply by 0.9 one more time to find out that its final speed here is 72. I multiply this by 90% again to find out its final speed here is 72.9 kilometers per hour. This is the same thing as starting with 100 and multiplying it by 0.9 3 times, so to the power of 3. This situation is a situation that involves a decay rate because the arrow is losing speed. And the equation that we could create is the speed of the arrow is equal to 100, that's its initial value, that's how much it's starting, multiplied by 1 minus the decay rate. The decay rate is 10%, and as a decimal, that's 0.1. 1 minus 0.1 would get us 0.9. And all of that to the power of x, where x is the number of force fields that it passes through. And of course, I could have just plugged in 3 over here. Passing through 3 force fields would give me the same answer that I got when I did it manually, 72.9 kilometers per hour. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.